Okay, you're given this implicitly defined relation and asked to find dy dx, or I'm going to use y prime. Here's the graph, part of the graph of this function. And you can see that the point -1, 0, you can test it out by putting -1 in for x, 0 in for y, and see that you do get a true statement for those values. So as part of this solution, on the next board, we're going to show that whatever we get for y prime does appear to give us the slope of the tangent line at the point -1, 0. And then we'll graph the tangent line to kind of show that. So here's the work. The derivative of ln of anything is 1 over the anything. Then you got to apply the chain rule. So the derivative of the inside with respect to x is 2x plus the derivative of y is y prime. The derivative of -3y is -3y prime. And over here, you have to use the product rule. So the first function times the derivative of the second. The derivative of the second would be 3e to the 3x plus the second function, e to the 3x times the derivative of the first. So there's what you get after doing implicit differentiation with respect to x. Now, if you want to simplify that and find y prime, normally I would probably multiply through every term by x squared plus y to clear the equation of fractions, but this time I'm going to distribute this 1 over x squared plus y times each term in these. So that's where these first two terms come from. And there's the repeat. Now I'm going to take all the terms containing y prime, get them on the left side of the equal sign. So this one was already over here, -3y prime, transpose the e to the 3xy prime, becomes minus. And at the same time, I'll take this 2x over x squared plus y to the right side of the equal sign. Now you can see that every term on the left contains a y prime. So I factor out the y prime and then divide both sides by the coefficient of y prime, which is this mess right here. So I've got this side divided by that expression on the right. I would probably, at a minimum, get rid of the complex fraction by multiplying top and bottom by the LCD of all the little denominators, which is just x squared plus y. So when I take x squared plus y times both terms of the numerator, when I take it times this term, the x squared plus y's cancel out. That's why I just have a minus 2x here. And then times every term in the denominator, these cancel out. But I have -3 times the x squared plus y minus e to the 3x plus x squared plus y. Now you could remove the parentheses, check to see if there's any similar terms, but I don't think there are. So this is just as good an answer as any. But if we go to board 2, here's what g of xy looks like. In terms of xy, where I actually did remove all the parentheses. And if I evaluate g at -1, 0, I get that as the slope of the tangent line at that point. And if I write the equation of the tangent line at the point -1, 0, it looks indeed like that is a tangent line. So I'm fairly confident that that is y prime in terms of x and y. Okay, there you go. Hope that helped. If you have any questions, post a comment.